All right, so Module 7, Homework 4, simplifying complex fractions. We want to simplify this complex fraction 3/4 over 1/5. So what a complex fraction really is a fraction in a fraction. A fraction in a fraction. So we have 3/4 divided by 1/5. So I want to rewrite this. 3/4 over 1/5. So I like to really bold that main division sign. So it's a fraction. I just gave away the answer. Fractions mean what operation? Add, subtract, multiply, divide. Divide. So I can rewrite this as a division as 3/4 divided by 1/5. We already did division. How do we divide fractions? Yep, so stay, change, flip, multiply by reciprocal, whatever you want to call it. The first one's going to stay the same. We're going to change our operation from division to multiplication, and we are going to flip our second fraction to get the reciprocal. Reciprocal means flip the second fraction. So the first one's going to stay 3/4. It's going to change from division to multiplication, and we are going to flip our second fraction. So we now have multiplication. How do we multiply fractions? Oh, thank you. Thank you. 3/4 times 5 over 1. Thank you. So now how do we multiply fractions? Straight across. Straight across. So we have 3 times 5 up top, which is 15, divided by 4 times 1 on the bottom, which is 4. Can I simplify this? Is there anything that 15 and 4 have in common? Nope. Final answer. Final answer. Questions for me? How could I help you? So if not, let's move on to the next one, simplifying the complex fraction. We have we have 4 over 3x divided by 2 over 9x. So this is our main division fraction bar that I'm going to rewrite as 4 over 3x divided by 2 over 9x. 4 over 3x divided by 2 over 9x. So we need to divide these fractions. So stay, change, flip, or multiply the reciprocal, however you want to call it. So our first fraction is going to stay the same, so 4 over 3x. Our operation is going to change from division to multiplication, and we are going to flip our second fraction. So 4 over 3x times 9x over 2. So now that it's multiplication, we can multiply straight across. We can multiply straight across. So 4 times 9x, help me out. 36x. All over 3x times 2. 6x. How can we simplify this? What if 36 divided by 6 will give us? 6. What happens to our x's? They cancel out. Thank you. So x divided by x is just 1. They cancel out. So we're just left with 6. So side note, if we have 4 over 3x times 9x over 2, from right here, some people like to simplify right here. That's totally cool. If you say, okay, they both have this x, I can cancel out. 9 divided by 3 will give us this 3 up top. 4 divided by 2 will give us this 2 up top. 2 times 3 is 6. You can do that as well. Either way. Either way. What questions do you have for me? Questions do you have for me? Ready for the next one? Simplifying this complex fraction, we have 2 over x minus 4 divided by x over x minus 4. You have to dance to be let in, I'm sorry. Oh my gosh, what a loser. All right, simplify the complex fraction. This morning I had a student come in and he's like, okay. He was like wanting to do it. And I was like, oh, I did. You really didn't have to. I was like, no, I want to. I'm like, okay, go for it. It was funny. It was cute. All right, simplify the complex fraction. 2 over x minus 4 divided by x over x minus 4. So we're going to rewrite it. I want to highlight our main fraction bar. So I can say 2 over x minus 4 divided by x over x minus 4. So we're dividing fractions. We can stay, change, flip. Stay, change, flip. So our first fraction is going to stay 2 over x minus 4. Our operation is going to change from division to multiplication. And we're going to flip our second fraction. So x minus 4 over x. Now we have it as multiplication. We can multiply straight across, just like last time. So we have 2 times x minus 4 all over x minus 4 times x. Notice each little fraction is its own factor, it's its own family, so you need to put it in parentheses to separate it. So now we have 2 times x minus 4 all over x minus 4 times x. What factors can cancel? X minus 4. What's left over up top? 2. What's left over on the bottom? X. 2 over x cannot be simplified. Boom, we're done. Questions, comments, concerns for me? Questions, comments, concerns for me? If not, let's keep going. Simplifying the complex fraction. 1 minus 2 over x divided by x plus 2 over 3x. So slowly getting a little bit more our speed. So this is our main division symbol, our main fraction bar. So I'm going to rewrite this as 1 minus 2 over x divided by x plus 2 over 3x. Do we agree so far? We just rewrote from the fraction symbol to the division symbol. So I know we want to stay, change, flip, but before I do that, I have different fractions going on. So I want to combine these into the same fraction. So forgetting about this stuff for a second, if I have 1 minus 2x, I want to write this into the same fraction. It's subtracting. How could I subtract two fractions together from last week? LCD, good. So I have to get a least common denominator. So if I have x, and this would be written as 1 over 1, what should be my LCD? Just looking at this side. Just x, yep. The second fraction's already had the denominator of x, so it's good to go. This first fraction needs an x, so I can multiply the top and the bottom by x. That'll leave us with x divided by x minus 2 over x. Ow. So I have x over x minus 2 over x. Are these like terms? Bless you. Yes. So now I can combine them into the same fraction. So I have x minus 2 all over x. I can't simplify that any further.
Squared? Or no,
It's subtraction on the bottom. It's subtraction, so I just leave it just as one of them. I can't simplify this any further, so it's done. Same thing for the other side. So, what is my denominator here? Over x.
3, 1.
Yeah, 3x, and then I have 1, so it's my LCD. 3x, good. 3x for that side. My first denominator is 1, so it's missing 3 and x, so I'm going to multiply the top and the bottom by 3x. My second denominator is already 3x, so it's good to go. So we're going to divide 3x times x, 3x squared, all over 3x plus 2 over 3x is already good to go. Now they're both over 3x, so now they're like terms, so I can combine them into the same fraction. So divided by 3x squared plus 2, all over 3x. There's no GCF up top. There's nothing else I can do to simplify, so it's done for now. So basically I simplified each side first, each little section first. Now I can worry about bringing them together. So we're dividing. So we can do state change flip. Our first fraction is going to stay, x minus 2 over x. Our operation is going to change from division to multiplication, and we are going to flip our second fraction. So now we have multiplication, so now we can multiply straight across. So I have x minus 2 times 3 times x all over x times 3x squared plus 2. So notice I wrote it as each factor separately. So that way I can see what factors can cancel. Factors are things that multiply together. So I have x minus 2 is its own factor, 3 is its own factor, times x, which is its own factor. On the bottom we have x times 3x squared plus 2. So what factors cancel out? X. So they cancel. Why can't those 3 cancels out? Why can't those 3 cancels out? Cancel out? Yeah, because they're not the same thing, right? Because this one is just 3, this one's 3x squared plus 2. Why can't those 2's cancel out? Why can't the 2's cancel out? Yeah, it's not the same factor, they're not like terms, none of that good stuff. So what's left over up top?
So how did you know to put the 3 times x instead of just putting 3x? Because
3 times x is the same thing as just 3x. I just wanted to write them separately, just so that I can see it clearer. Just kind of like writing it neater. Because 3x is the same thing as saying 3 times x.
I know, but
You
then
don't
why
have to write it.
why wouldn't it be able to cancel?
That's
just 'cause
yeah,
the
she's asking why.
square.
Because I was wondering that too. Instead of
Say
it
what?
3x and then it has 1x at the bottom, why doesn't it make it 2x at the top? Could you subtract?
One more time, I'm sorry.
Like if you go back to this one
This one.
and it's just 3x over 3x squared, like take away the 2 and all that. Why wouldn't
Just
it be
looking
able,
at this side.
yeah?
looking at
Why
this
wouldn't it be able to cancel it out and just leave 1x left?
These two?
Yeah.
Because these are not the same thing, because this thing is being added, so because they're being added together, it's its own factor. So they cancel the one factor.
That's not what.
Okay, what were we saying?
So it's a 3x and then the x at the bottom. Why doesn't it make it 2x at the top? See the x by itself?
This
and
one?
then divide the 3x divided by that x.
Yeah.
Will make it 2x, right? That's where I'm confused.
Okay, so whenever you multiply, you add them together, right? We're
Yeah, but
dividing. Whenever we divide, you subtract. Bingo. So then it's 1 minus 1, we have 0. X to 0 power is 1.
Oh.
Nice, because you remember the exponent properties. That's good. I know that it's not what we're talking about, but it's good. It's a good mistake. That's good. Yeah, because we're dividing, we subtract. So if we have 1x here minus 1x here, that means we have 0. I can't talk to it. It means we have 0 x's. That's why they cancel out.
Okay.
That's
It
good. That's
just was
good.
a different way I was looking at it.
Yeah, so you're looking at it from the right when you multiply, you add. Is that what you're talking about? That's good. You're wrong, but it's really good. Okay, what else? Other good questions. Other questions. What's left over up top now? 3 times x minus 2. Good. All over. Come on. 3x squared plus 2. Good, thank you. Why are you guys so quiet? It's because I was excited. I told you guys I was so excited for today because I love you guys, and then you don't talk to me today.
The 3x squared plus 2 now.
Yeah.
Just to distinguish between them, is it only the difference of perfect squares where you do the x plus 2x minus 2?
Right.
So that doesn't come into play because that 3 is in there, right?
Right, because a difference of perfect squares, difference means subtracting, for one. And it has to be, this has to be a perfect square, and this has to be a perfect square.
Oh,
3 is not a perfect square. 2
okay,
is not.
so pretend that didn't say anything.
No, but that's still a good question. That's still a good question. But you're right. So looking at this 3x squared plus 2, I can't factor it. So it's not a difference of perfect squares. I can't factor this, so it's done. If we could factor it, we would. So you're thinking on the right track. What else?
That's the answer
Yes.
right there.
That's the answer right there. Yes, sir.
Does it make a difference if you put the parentheses x minus 2 first?
No, that's okay. This is a little bit more grammatically correct because it kind of looks a little bit better, but it's okay either way. I wouldn't take points off. Grammatically, that's a different story. I think it'd be okay. Other questions? Thank you for asking. Yes, ma'am.
So why wouldn't you distribute the 3 at the top?
You can, but that would just be more work, and I don't want to do any more work. I got plenty to do. That's fine. So we just leave it. Leave it factored for. What else? Finally talking again.
So if you do go ahead and distribute the top,
Right?
my math lab will mark it wrong, correct?
I believe that it's still the same thing. So just like David was asking about x minus 2 times 3, either way, it would be the same thing. So if you were distributing the 3, it'd be 3x minus 6. It's still the same thing. It's just more work, so I didn't want to have to do it. We can leave it like that, but I believe it'll still mark it right because it's still the same answer. Or worst case scenario, it'll give you the whole, oh, your answer's right, but not in the right form. Which is real.
Yeah, it's not you, it's me.
Exactly. All right, ready for the next one? Good, thank you guys. That was good. Good talk. I feel like I'm getting you guys back again. So, speaking of difference of perfect squares, even though I kind of give you the answer right here. Simplifying the complex fraction, 9x squared minus y squared, all over xy, divided by 3 over y, minus 1 over x. So for one, let's go ahead and split these up so that way it's not so overwhelming. I think that's the worst part about these is it looks so bad because there's so much going on. So I want to make it a little simpler. So I'm going to rewrite it separating each side. So we have 9x squared minus y squared all over xy divided by 3 over y minus 1 over x. So I just rewrote it instead of as a fraction using the division sign. Speaking of which, so this first one, it's already in one fraction, so that's good. So let's try to simplify this one fraction. What do you notice, even though I already kind of gave you the answer? Difference of perfect squares up top. I notice that 9x squared is a perfect square, 3x times 3x. Y squared is a perfect square, y times y. We're subtracting those. So we can factor using a difference of perfect squares. So we know 9x squared is 3x and 3x. We know y squared is y times y. One's positive, one's negative, all over xy. So we factored it, but unfortunately nothing cancels. But it's kind of ready to go now, so that one's done. So that first one is done. Divided by 3 over y minus 1 over x.
Stay, change, flip.
Yeah, we're gonna say you're ahead of the game. Stay, change, flip. You're right. But before we do that, I need to just focus on this side and get them to be the same fraction, the same as one fraction. So I need to subtract? LCD. Thanks. I was stumbling there. So what should be my LCD if we have y and we have x? XY. So XY should be our LCD. This first denominator has y, but it needs x. So I'll multiply the top and the bottom of the first fraction by x. The second denominator has x, but it needs y. So I'll multiply the top and the bottom by y. That will leave us, forgetting about this side for a second, with 3x over xy minus 1 times y is y over xy. Again, we're forgetting about this for a second. So now these are like terms, so I can combine them into the same fraction. So now I have 3x minus y all over xy. So 3x minus y, that's factor. There's no GCF. Nothing can cancel from the top and the bottom. So that side's done. So I dealt with the left one separately. I dealt with the right one separately. So now I can worry about stay, change, flipping it, and putting it all together. Oh, it's still recording. I'll have to cut some off of it.